Problem 452, minimum number of arrows to burst balloons. So to solve this problem, we need to know how the problem criteria is given to us. And it's very simple. So basically, we're given a bunch of balloons, specifically how far they stretch in the x direction. So in the points array, we have a bunch of subarrays. And each of the subarrays contains two elements, the starting x position and the ending x position. So basically, all the balloons stretch a certain amount in the x direction. And we shoot arrows up in the y direction. And basically, how do we shoot as few arrows as possible to pop all balloons? And we pop a balloon so long as, if we shoot an arrow at x is equal to n is within the range of x start and x end for each balloon inclusively. So how do we solve this just from intuition alone? Like when you first look at this problem, what is the first thing that should come to mind? Well, we want basically one arrow to pop as many balloons as possible. So what that translates to is we should shoot arrows where the balloons overlap. So we should shoot an arrow within this range, not here, right where this dotted, right in this region right here. But in this dotted region, we have another problem. There's a lot of points to choose, right? Which of these points should be used to shoot down the balloon? Well, it turns out we should always choose the endpoint of this shared region. And the reason for this is kind of intuitive, because let's say that we sort all balloons by their starting and by their endpoints. So it could look something like this. In this case, which of these balloons and which positions should we shoot? Well, we should shoot at this position, because by shooting at the balloon with the earliest end time, we maximize the possibility for that point to be included within other regions of other balloons. And why is this not the case, for example, for the start? Well, if we shoot at the start of these four balloons here, then we're only going to pop these two. We're not going to pop any of the later balloons, because since this point starts at the earliest possible time, or rather it starts at the earliest possible x position, then it decreases the chance for that point to be located in the x span of later balloons, right? That just very intuitive. So if we choose the latest point at which the balloon stretches to, then it maximizes the chance that the point that balloon stretches to is included within the range of other balloons. And that's why you always shoot at the earliest endpoint of the earliest balloon, with the earliest endpoint, of course. So once you choose this endpoint, you basically then iterate through every single balloon to see if that point is included within the range. If it is, we move on, because that arrow is going to shoot down that balloon. So then once we get to here and then here, we notice, well, this range does not include this point. Therefore, balloon 1 and balloon 4 are mutually exclusive. They don't share any overlap. Therefore, we need another arrow to shoot down balloon 4, which again we're going to shoot at the endpoint of that balloon. And with that, we can program it up in Python. To sort it, we use this statement. And basically, sorted is a method, and we're sorting what? We're sorting points. And this is just basically the syntax you need to basically say, well, sorted based on the second element of the inner arrays within points. So that's just, syntactical sugar, and you just need to know this. Well, this basically then, once it's all said and done, sorts the points in ascending order relative to endpoints. Well, now what? Now we have to keep track of where we're shooting the arrows so that we can determine if that arrow position can shoot down each balloon in the points array. So let's call that arrow position to be equal to points of 0, 1. This is going to be, well, the first arrow we need to shoot down the first balloon. Therefore, we have used up one arrow already. So now what? Now we need to see if the arrows are going to shoot down the subsequent balloons. So for I in range of 1 to length points, we're going to do what? If the arrow is within the bounds of the points array, or within the bounds of the points element that corresponds to a given balloon, then we do nothing, because that balloon is all good and set. We just need to keep track of the arrows that don't shoot down each balloon. So it doesn't shoot it down if not what? If not, the points of I0 is less than or equal to arrow pose, or not points of I1 here, and then arrow pose being less than or equal to that. So this is where we have the arrow position that we shot it at to be not within the range of the proper balloon, therefore it won't shoot it down. Therefore, we need one more arrow, r plus equal to 1, and we're going to shoot that one extra arrow at the endpoint of the current ith balloon. And with that, we just return r once we're all done, which should work. Which it does, so let's submit. And it passes everything.